Welcome to this topic video on JSON Schema. What is this about? It's about validation, input validation. Huh? What do you mean? Okay, let's say you've got a browser app running in the browser. Simple checking of input fields, okay? To more complicated checking of multiple input fields for compatibility, okay? You're having people fill in stuff. Did they put in valid inputs, okay? Web apps that load data may need even more elaborate type checking of complicated data structures, okay? Right? We saw that we can get make arbitrarily complicated data structures in JSON format with objects within arrays within objects, etc., etc. Okay, so we have a need to check that stuff. Okay, and remember, on the server, JSON data from a client can never be trusted. Okay, you just don't do that. You can, right? That's a form of attack vector. Okay, so we have to check that data. Okay, always be checked for general and application specific requirements. General meaning like, did somebody send you 2 megs worth of data when you were expecting less than a K? Yeah, that shouldn't be good. And does the application specific requirements is this the format that we expect this data to be in, right? Okay. Some of this is due to JavaScript being a weakly typed language, right? Okay. Now, performance and security can be very important, okay? We need to be very clear about what our APIs will accept, okay? So, we're on the server. We learned about REST and other ways to design APIs, okay? But we didn't get down into like, what's the exact format of the data and how to ensure that. Okay, so what's happening in the world of validation checking? So I checked around a little bit, okay? The most powerful schema description language and data validator for JavaScript, okay? Happy/joy, okay? 4 million downloads. Sounds pretty popular. Then I remembered a while back, I did some stuff with JSON Schema, and I looked at another JSON Schema validator. Nothing wrong with that previous project. I'm not making any comparisons or anything. Okay? 30 million downloads weekly. Okay? Oh my gosh. Okay? I guess people are using this. Another JSON schema? Wait, we know what JSON is. But what's a JSON schema? Let's find out. Okay. A JSON schema, a way to specify the contents of a JSON file or message or JavaScript object/array. Oh, that's right. We don't have types. We have just objects, right? Okay, we can have classes and stuff, but they still don't, right? We can change what's in a JavaScript object on the fly, right? No constraints against that. So how do we know what's going to be in the JSON file or message or JavaScript object? Oh, well, that sounds kind of useful. Okay, so there's a main resource site, jasonschema.org. The main reference, structural validation. Okay, schema validation vocabulary for structural validation of JSON. Oh, professor, no. Don't, we have to be formal when we spec these things, but the things are designed to do something specific, okay? So don't let formal language freak you out. Okay, there's step-by-step tutorials, and there's an online book, okay? So let's get the flavor of things. Okay, so the question is, how can we tell if a JavaScript object is valid in our application situation or application context, right? We expect certain things to be in that object, Maybe we don't want other things to be in that object, and those things in that object have to have certain constraints on them. Now, typical thing we do is write a test function, okay, or a program, but a function to check for the presence and absence of various fields and check constraints on those fields. Okay, what else would you do? Makes sense. It seems like a lot of people would have this functionality. Maybe somebody else has looked at this before. What do you bet? Yeah. Okay. In order to check the validity of a JSON object, we need a way to specify what should or should not be in that object. We need a language to describe a JavaScript or JSON object. Okay. Such a language used to describe things is called a schema. Okay. This comes from the database-ish world originally-ish, kind of to me. Okay. They can take a number of forms. Okay. There's not one way of specifying a schema and stuff like that. Okay. There's been a number of competing ways to specify schemas. Okay. Now, the approach we're going to take to describe JavaScript objects in JSON, yeah, will be written in JSON itself. Oh, Professor, that hurts my head. We're going to use JSON to describe JSON. Yeah. Can we do that? Yeah, we can. Okay. The particular flavor we're going to use is very popular, is known as JSON Schema. Okay. Great. Okay. So tools for when we're developing these JSON schemas. Okay. There's an online schema validator. Okay. So on one side, I put in this thing called a schema. Okay, here's a custom schema. Then I put in some JSON and I try to see, and I check to see, well, it checks for me, no errors found, JSON validates against schema. Oh, okay, Professor. Or there's some tools. Okay, I've installed the AGV CLI tool globally on my machine so I can just check things. I go AGV on the command line, minus S for schema, you give it the schema, and then minus D for the data to see if things check. Okay? So let's take a look. Okay? Let's take a look at a fairly simple schema. Okay? Now, it's got stuff in it to help you identify what version. Because there's versioning issues as they've updated how we describe data. Okay, we have things complying to different ways of doing that. Okay, so this first line here helps specify that. The ID is for us to specify. Okay, so I go grottonetworking.com because I own that domain. Then I say example1.schema, schema.json. Doesn't mean I'm putting this thing up there. It's just a unique way to specify it. Okay, my first schema, description, okay. All this stuff is kind of like overhead. This is where we get down to it. I say type object. Okay. What does that mean? Okay. It means I'm expecting an object. What things can I say for type? I can say I expect a string. Numeric types. I can say I just want an integer, or I can leave things as a general number. I can impose range restrictions, okay? Size things, right? It can't be negative, etc. I can say it must be an object. If it's an object, I can specify its properties, okay? I can specify which are required, okay? Which ones are optional, which ones are required. I can also specify whether additional properties are allowed. Oh, that sounds useful, Professor. Yes, it does. Okay, I can say, should it be an array? Should it be a Boolean? Oh, and I can put things within things within things because that's what we can do with JSON. Oh, so we can specify all sorts of stuff. Yeah, so let's go take a look. We got schema1 JSON. Okay, what do we see here? We see it's expecting an object. Okay, let's try running a test. Here's an object. Okay, so we're going to come here to our command line. We'll try the command line version for this version. Okay, and I'm going to say agv minus s x1 schema.json minus d x1 test1.json. And it says x1 JSON is valid. Cool. I said it should be an object, and this thing is an object. Let's try test 2, though. Test 2 is not an object. Test 2 is an array. Run the validator. Okay, here's same schema, and test 2, which corresponds to this array. I'm going to hit enter. Boom. It says JSON invalid. It doesn't pass muster. And then it gives me some information. Okay, parameters type object, message. Should be object. Oh, okay, so it gives me information also, at least this validator does, on why it didn't pass the test. Okay. What kind of validation rules can we have? Okay, we saw type. Things can be null, boolean, object, array, number, or string. And remember, okay, we can specify what's inside those things too. Okay, that's a separate thing because we have the nesting like in JavaScript. Okay, enum. Let's say we have a fixed number of values. Okay, let's say the type is string. Okay, and only a certain number of values are valid. We can give that as an array. So let's say we had a days of the week string. Okay, and we could say it's got to be Monday, Wednesday, Thursday, Friday, blah, blah, blah. Okay, we can give that as an array. Okay, another one is, the certain value for right now can only be one value. Okay, so we can have like an enum with a single value, and that's a const. Okay, so we have type, fundamental, and we have these additional things that we can put on any type, okay, any instance field. Okay, now for things like numbers, okay, we can have things like it must be a multiple of. We can put a maximum. We can put must be up to a level, but not over, including that level. We can have minimum, exclusive minimum. Oh, so we can do ranges, yeah. Now, this isn't the end all. You can't do all tests this way, okay? But you can do a lot. Strings, max length, min length. Remember, we said, we want to sanity check input. We don't want people trying to put a lot of weird stuff in to try and do things. If it's a name, we can limit it to 100 characters, okay? Okay, we can put in patterns. They have techniques for doing this, okay? If we have an array, we can limit the number of items. We can make sure there's a certain amount of items. Maybe we have uniqueness criteria, okay? Etc. Okay, so these are the kind of rules you get. Okay, so before we have to go to any custom checking, we should try and get as much out of a schema like this that helps do checks. Okay, objects. We can put requirements or maximums on the number of different properties in it. Okay, we can make certain properties required. Okay. We also have additional properties. Are they permitted and such like that? So let's see an example. Okay. So let's see. Oh, this is not highlighted nicely. Let's go look at the example in our. Let's go look at example 2 schema. Okay. So what do we got here? Oh, title, windsurf foil. Description, for the most fun, use a foil. It's an object. Since it's an object, we can specify its properties. Oh, I see how this gets recursion. Inside We have a property named front wing. Oh, we can spec its description just like we did outs. Yeah, you got it. We can get nesting. Length of the front wing in centimeters. Type integer. Why not general number? Up to an integer's centimeters, close enough for our business here. If you don't like that, you can go to number. Rear wing, okay? Length of the rear wing in centimeters. Color, description, the color of the foil, material type, string, required front wing and rear wing, okay? Additional properties, false. Let's check this out. Let's see how this works. I have a bunch of different tests for it, okay? Front wing, rear wing, and stuff like that. But let's do this one in the online validator, okay? Partially. Look, I already put it up in here. What's that for? Format. Okay, so here we have title Windsor foil, foiling for stuff like that. We got front wing, rear wing, color, black, material, okay. No errors found. Is it talking about this or this? Well, let's see. Let's remove one of these properties. So X. Found one error. What's the error? Required properties are missing. Object front wing. Oh, that's right. We said required front wing, rear wing. Let's put it back. Is it okay to remove the color? Oh, they don't care about the color. Is it okay to remove material? Okay, that seems okay. Let's put in a new one. Let's go owner Dr. B. Found one error. What's the error? Property owner has not been defined and the schema does not allow additional properties. Oh. Cool. Okay, so we're not letting them stick stuff in. Here's one. Go with a negative number. Oh. Over here we didn't, it's letting the negative number in. Oh, type integer. Maybe we need to go like min. What's a reasonable min? I don't think anybody's going to have one of these less than 10. Okay, but that was for the front wing. So let's do the rear wing. Same thing. Let's add min 10. JSON validates against schema. It's got a minus in it. Whoops. Well, we'll see what's up with that another time. Okay, back to the lecture. We'll have to study that one to get our rule right. So don't try and wing things, kids. Okay. So we saw these examples. Now, let's see another example. How about an array of objects? How would this work? Okay. So this is for network demands. Network demands? Yeah, like in a communication networks. Okay, so let's go with net schema, demand schema it should be. So these are network demands. Okay, so what do we have here? Demand format for import and export by Dr. Graham Bernstein. This works with ComNetViz, which is a program. And so what we mean is we have, we'll just look at an example network. Here's an example network, a communications network, okay? And what we do is we specify view, so there's path info, we're going to view network info. Okay, we can view, okay, we see the various communications links between these nodes. Here's a list of the nodes and such like that. We want to talk about how much demand we have between any two nodes. Oh, well, that makes sense. So let's look at the schema that I came up with for that. Okay. So, demand schema. Okay. First of all, oh, type object? That's a, wait a second, we'll get to the array of objects. Oh, first I'm going to give the demands an ID and a description. Oh, because when you do network optimizations, you're going to probably throw a bunch of different demand scenarios at your optimizer and see how it does. Yes. Now here's where we get the array. Demand list, type array, items. We're going to specify the items that have to be in the array. The items have to be of type object. Each of these has properties. It has to have a source, where the communications are coming from, and a target, where the communications is going to. And it gets a number, a demand number, okay? Oh, I think we just found out my mistake. Minimum. Let's go try fix that. Okay. It's not min, it's minimum. Okay. And this is going to be minimum. Okay. Minus 20 is less than the minimum value of 10. Okay. Gotcha. Okay. There we go. Mystery solved. Okay, so where were we? We were looking at this schema that included an array of objects. Okay. So let's try some tests with this. Demand schemas, we need some example demands. Okay. And this is way more complicated than that one before. Okay, so let's take this. Let's use the online validator. Okay. Guess it's a little more graphical, so I'm going to just select all, paste in. And first of all, this object we know is not going to satisfy the schema because it doesn't have the things that match. Required source target, required demand list. There's no demand list in here. Okay, so let's go get some data that may or may not satisfy the demands. Okay. That's a network. We need some demands. Okay. Demands schema, Chinese network demands 1. Okay, so here's some source destination nodes. Not of the network we were looking at there, but a different network. Okay, now we'll come over here to our validator. Select all, paste in our new stuff. Expected object begot an array. Ooh, this is not valid. Let's try another one. Chinese demands 2. Stuff. Try that one in there. Required properties missing from object. Demand list. This won't cut it either. It's got an array. It looks like the stuff in the array is right, but the array doesn't have the right name. Oh, professor, it's really picky. Of course, you need it to be this picky. Okay, demand list. Okay. Try this one. Okay. Because we're going to be assuming that we get objects with specific format, meaning they have properties, okay, with specific names, and that they will have specific value types. Yeah, we can use this to check that for us, okay? Now, in the examples, I go even more complicated, okay? So here's a good example data and such like that. But I go to an entire network schema that I use actually here to validate the inputs here, okay? For the networks, what the networks themselves look like, okay? So as you might guess, that can get quite complicated. We have things called nodes, which are the switches in the network, okay? We have links. They can have many different properties, capacity, weight. We can have all optional things like ports and stuff like that. Okay, we have certain things that are required. Okay, other things that are optional, like here we say layer or IPv4 address or MAC address. Okay, so this is a schema that I use in this ComNet viz. Okay, now, so you go to use this stuff. Okay, what else is it good for? Well, it lets the person receiving the data, well, when you publish your API, it's also good, very good, for establishing in a precise format what you're willing to accept, okay, from the user, okay? And when I mean user, I mean you've got an API for your server, you specify, use the JSON schema to specify the format of the data so they know exactly and they can test it beforehand, okay? And we have it, okay? Oh yeah, testing. Okay. So that's a quick intro to data validation and one technique, I'm not saying it's the only technique to use, for dealing with fairly complicated data that we might be using on our server, sending back and forth from our server to our clients, and we can use this stuff to help on the clients too. Okay, all right, let's go code.